Hi guys, I want to introduce you guys to the Tic Tac Toe 10 platform that I've created. Let's go Tic Tac Toe 10. I'm going to show you a couple of concepts that I think will be useful to kind of change the way that kids might look at simple education, arithmetic, and putting words together. This platform that I'm about to show you is something that I think will be very powerful in transforming the way that kids look at learning. I'm going to trick them into having some fun. Okay? So we call it Tic Tac Toe 10 because, as you can see, there's one large grid and then there's 9 small grids embedded into it. So I'm going to take you through 3 concepts, one with X's and O's, one with numbers, and one with letters. Okay, so for the one with X's and O's, this is the game version of it. So let's call just before we start, let's call every upper left hand cell 1, 2, let's call this one 3, 4, 5, 6, 7, 8, 9. That'll be consistent for everything here. So X can start this game and choose wherever they want to go. So let's make a move inside of small grid 7. 1, 2, 3, 4, 5, 6, 7. You see that's where I made my mark. Now it's O's turn. So what happens is, because I made my mark inside of small grid 7 here, if you look at the large grid and count 1, 2, 3, 4, 5, 6, 7, O's next move must happen somewhere inside of here. So in effect, X has sent O to this grid here where he can make his next move. So let's say we select 6. So we put an O in 6. So same thing happens if you count 1, 2, 3, 4, 5, 6 here. That does the same thing for the large grid. 1, 2, 3, 4, 5, 6. X's next move must take place somewhere inside of here. So that's the basic mapping system, where every move that you make translates into the next player being sent to somewhere else. Alright, so let's say we send O right back here to 7. Let's say O moves in 9 here, sends X right here, and let's say, just to keep it short, that X sends O right back to 7 again. The object of this game is to be the first player to win tic-tac-toe 3 in a row inside of any one of these 9 small grids. So since X has sent O back to 7 3 times, O's had the opportunity to make 3 marks in a row. Okay, so that's X's and O's. Let's cross that off. Let's say we wanted to get into the educational component of this, and say we take all of the X's and O's out of this and put in numbers. So let's say we randomly had 81 numbers here, and I'm going to throw some operators down here on the bottom, a plus, a minus, a multiplication, and a division. And the idea is that kids would have this on a mobile device or a smart grid or smart board that a teacher would have in the classroom. And let's say, just to keep it simple, that there are 81 numbers populated into this grid to start the game off, and I give a kid, let's say, 1 minute on the timer. So the object of this game with numbers is, let's say we put a 6 here and a 4 here and a 10 here just for starters. There would be 81 total numbers populated to the grid to start the game. Start timer, and it begins to run down. The object of the game is the kid has the opportunity to press any of these mathematical operators on the bottom, and then based on what he presses, so if he presses plus and he starts with this 6 here, we've got 6, which sends us to this grid right here. We've got 4, which sends us to this grid right here, and we've got 10. So since I've chosen plus, the object of the game is to find as many number triplets as you can that are correct arithmetical statements. So obviously 6 plus 4 equals 10. So this triplet would disappear and the time would still be running down. So the object of the game, or to get to the next level, the child would have to find, let's say, 5 triplets that work, and then you advance to the next level, and then another 7 to get to the next level, and then 10 for the next level. So that's the idea behind this one. And as you find triplets, the 3 disappear when they're correct statements, and then you have less numbers to work with. Okay, you can do the same thing for subtraction, multiplication, and division, and that's the idea for the number game. And then in the same way, if we were to take the numbers out and put 81 random letters in each of these grids here, what would happen is it turns into like a word game. So say we want to make a 5-letter word. I don't know, let's do lives, L-I-V-E, and let's say S right here. So there'll be 81 letters on this grid to start the game. We have the same timer that starts, and then we say, okay kid, find me as many words as you can under this 1-minute time constraint, and if you find enough, then I'll send you to the next level, and if you don't, then you can play this level again until you get it. Alright, so the kid says, okay, I'll start with L here. This grid sends me over here. Start with L, we've got I. That one sends me over to grid 3. We got V. Okay, L-I-V, that sends me down to 9. L-I-V-E sends me to the center. L-I-V-E-S. 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 We've got lives right there. And then we'll do the same thing with all of the rest of the letters that would be populated into this grid. There'd be a dictionary function that would check the validity of the word that they enter, and that would be how that game operates. So this is just a platform. I call it Tic Tac Toe 10, but it's definitely not just a game. It can be a learning platform where kids can take advantage of some simple arithmetic type things and some simple word construction, and then there's other things in the future that we're working on. So excited to share more as those developments become available. Alright, hope you guys understood and enjoyed.